Welcome to the basics section of the Community Microgrids Planning Academy. Here we will provide introductory information on what microgrids are, the benefits they can provide, and the challenges that can sometimes be faced in creating one, and the systems and technologies that are used to create them. The basics discussion is designed to set the stage for two other core sections of the Academy. The development process section provides a high-level overview of all the steps necessary to develop, build, and operate a community microgrid. Creating a microgrid development plan is a critical first step in this process. So we have also included a special section on planning that provides guidance on the steps needed to create such plans for your communities. All three sections work together to provide a solid introduction to what a microgrid is, how the process of developing a microgrid unfolds, and where microgrid planning fits in. The basics section of the Academy is organized into four interrelated subsections. What is a microgrid? What are the benefits and the challenges of creating a microgrid? What are the key components of a microgrid? And what are the key technologies used in a microgrid? So let's begin at the beginning by defining what a microgrid is. To help understand what a microgrid is, we'll begin with a brief overview of how the main electrical grid works, and then take a look at what defines a microgrid and how it differs from the macrogrid. We will then review four basic types of microgrids, and we will end with a short discussion on the evolving relationship between microgrids and the utilities. The U.S. electricity grid is a complex and incredibly important system, and one of the most impressive engineering feats of the modern era. It transmits power to more than 140 million customers through a network of more than 3,000 utilities across 300,000 miles of transmission and distribution lines, powered by 7,000 power plants, and it does so every minute of every day, year-round. The national electricity grid consists of 6 components in 4 broad categories. Generation assets, which includes generation plants or power plants that generate electricity mainly by burning fossil fuels, but also by using hydropower and nuclear energy. Transmission systems that include step-up substations to increase the voltage of the electricity to efficiently transmit it over long distances, and transmission power lines that transmit the electricity over long distances at high voltage. Distribution systems that include step-down substations that decrease the voltage so that it's more usable, and distribution power lines that transmit this electricity to the end user. Finally, customers/end users, where the energy is finally consumed. A microgrid is a localized power grid that serves a small network of electricity users, typically buildings or infrastructure, within a small, clearly defined geographical area. It's somewhat like a smaller version of the large electric grid. Typically, but not always, it's connected to the local utility at what's called a point of common coupling, where it can buy and sell electricity. Power is generated from distributed energy sources, such as combined heat and power systems or renewable energy, located within the defined geographical area. The whole system is designed to easily connect to or disconnect from the larger electrical grid so that it can operate in grid-connected mode during normal conditions or in island mode during power disruptions or when the economics of operating in island mode are favorable. There are 4 basic types of microgrids: off-grid microgrids, nanogrids, campus microgrids, and community microgrids. Let's take a closer look at each type. Off-grid or remote microgrids are not connected to the utility grid. They supply all the electricity needs of a building and are often used in areas where it is economically unfeasible to use or extend the utility grid. Remote microgrids operate in island mode all the time. Nanogrids, as the name implies, are typically small, single-building microgrids. They can meet some and sometimes all of the building's electricity needs, but they are typically grid-connected and can island if properly wired and controlled. Larger single-building microgrids are becoming more common as power generation technology evolves. Campus microgrids are usually large and typically connected to the utility grid. They are characterized by single ownership, a university, a large hospital, military, etc. Typically, they are a mix of multiple power generation systems, not just PV or CHP, but some combination of multiple systems. A community microgrid is a grid-connected microgrid operating multiple sources of power generation and delivery, often including heating and cooling. Community microgrids can vary in size and are customizable to meet a municipality's particular community energy needs. A key characteristic of community microgrids is that they deliver power to a cluster of independent facilities, unlike a campus, often with multiple independent owners, in order to provide a range of essential services to the public during and after emergencies. Properly designed and implemented, community microgrids can provide significant cost and efficiency benefits to municipalities during blue sky conditions, and at the same time, significantly improve a municipality's resilience to the impact of hazards and power outages. New Jersey is one of the leading states in the country in promoting and supporting community microgrids. A community microgrid has a complex but symbiotic relationship with the local utility that is mutually beneficial. The microgrid is a customer of the utility, using the utility's power supply when it is economically beneficial, and the microgrid can supply power and other energy services to the utility. Advanced microgrids also have black start capabilities, which means that generators can start up cold, supplying power without interruption so that customers are unaware of the shift between the grid and self-supply. The Institute of Electrical and Electronic Engineers has created standards and best practices for safe microgrid islanding, black start operations, and grid reconnection.